So welcome back to the video of module 5 of TOC. So module 5 alli they will ask you to design the Turing machine. Adon bitre everything is theory and you can score good if you have studied theory properly. Okay, and theory alli ನೀವೇನು ಆನ್ಸರ್ಸ್ ಬರೀತೀರಾ they will expect some keywords to be written as it is. So ಅದನ್ನು ಬರೆದ್ರೆ you will get complete marks. So let's get started. First question they will ask is explain the church Turing machine. Athwa if they ask only Turing machine also it is same. Okay. First let me tell how it works so that you will understand it in a better way. So always remember that Turing machine will not have the memory to store. Like, okay, I have stored this many number of letters only. So it doesn't have that memory to store. So it will have some, we have to match with the way to know that okay this many letters I have read. Okay, for that in the starting and ending we will have blank space. Okay, and let us say that there is some input. Okay, these are all of the inputs. So either it can read or write head. This is called as read or write head because Turing machine can only read and write. And in this there are two situations, whether it can halt and accept or halt and reject. Okay, so first what happens is, so you are clear with the Turing machine, right? So it can read and write and it has two blank spaces in the starting and ending one, and we have something called as control unit. So in control unit we have finite control state. Okay, and in that we will have multiple states where each will be connected to one particular states. First what happens is, now let us assume that this is the Q0 state. Okay, so it will read this Q0. Okay, then it will check. Always remember, if Turing machine wants to read any symbol, it will check in the head. So this A is the head, so it will check and read the symbol under the head. And if it wants to add anything or add the new symbol or move forward anything, it can add. Then based on the decision it can move towards right side or left side. And after you move from one state you will go to another state. That is the steps been written here. So it will start from Q0, it will read any symbol under the head, then it will write any new symbol and later shift towards left or right and enter into the new state called as Qj. Now this Q, that is Turing machine, has 7 tuples where Q is the set of states which is finite, alpha is the finite symbols, okay, input symbols, and this is nothing but set of tape symbols, and this is transition. Q0 is the initial state, B is the blank space, okay, and F is the set of final state. Blank symbol, okay, B stands for blank symbol. And in case of transition you should write, like, transition happens if from one state it is doing something, okay, X is nothing but the tape symbol here. Okay, then after this where it will go to something called as PYO, where P is the next state, Y is the symbol, and O is the direction. Okay, this is the theory part. Now let us go to the numericals. Before going to this thing, okay, there is one more question, that is note on multiple Turing machine. We will solve one question and later go to the theory part, okay, because it will be boring. So they have asked us to design a Turing machine for 0 to the power of n and 1 to the power of n. Okay, and the condition is n must be greater than or equal to 0. Okay, so I will tell how this actually works. So in the question, I'll write the question again. So in the question they have given L is equal to 0 power n and 1 power n, where n is greater than or equal to 0. Okay, so we can consider any number of zeros and any number of ones. Okay, now how this will work I will tell you first. So we know in the Turing machine we will have blank space in the beginning and blank space in the end. So in between we can read the zeros and ones. So I'll consider the string to be 0011. Okay. Okay, if this is my example, what will happen we will see now. Okay, so starting I will read this 0. Okay, so that will become my Q0 state. So from starting I will read 1 0. See, now I want to keep in track that number of zeros that I read must be equal to number of ones, because n, right? So both must be same here. N value here, whatever I take, if I take n equal to 2, here also I must be taking n equal to 2 only. So in order to keep in track of number of zeros must be equal to number of ones, I am going to use one method, that is, see, now in first case what will happen, I will read this 0 and make it as x, and I will move towards right. Okay, so here also I have read 0. Same thing, whatever I told in words I will write here now. I have read 0, I am making it as x, and I am moving towards which? R, right direction. Okay, then as I go on I will get this zeros, right? So I can get any number of zeros, because here in this example I have taken 2 zeros. It can be 3 also, 4 also, any number. So that is why once I go to Q1, I'll get here many number of zeros. If my string was big, you will understand, right? So I can get any number of zeros. Even though I see those any number of zeros, I will not change anything. I'll keep that as 0 only, and I'll still keep moving towards right side. Okay, that is the meaning. Then next is until I get 1. Okay, until I get 1, I need to wait. So whenever I get this 1, okay, first time when I get this 1, I will make this as y. Okay, so 1, I am making it as y. So then again I have to come back, make this 0 as x, and later move. Okay, so come back means I am going back towards left side, right? So it is comma L. Okay, and the next state is Q2. Okay, see, now as I am coming back, okay, as I am coming back from making this 1 as y, I am coming from this place, I am coming like this. So once I am coming, what all I can see? I can find 0, right? Also I can find x if it is many. Okay, so what all I can find here, that you should put in a loop. While coming back or while going, whatever extra you can find, that you must put in a loop. I can find 0, I'll still keep it as 0, I'm not making any changes, and I'm coming towards left side. Also I can find y, because see, from this place you're coming back means obviously you will encounter this y, right? So I can also encounter y. So y comma L. You're not making anything, you're just seeing and still coming back towards left side. That is the meaning. Okay, so that coming back also you should represent, right? So like this you're going to write it. Okay, so you have already come towards left side now, like this. Now again you should go towards right side, make 0 as x, go, then reach 1, then again make this 1 as y, again come back, again check. So same thing will repeat, right? So to repeat that same thing, here it is x comma r. Okay, once you have done all zeros as x and this thing as y, okay, this side will be y, because once you have completed all x and y, okay, again you will go on this path only checking like, oh, okay, I have completed everything or not. First you will encounter x, that we have written already. So y also we will check, right? So yes, it is y only. So hence here it is y, right. Even you see any number of y's, you'll keep on going. Okay, so this state will become something like x comma y comma r, because as you go you can encounter both x and y. Okay, so that is why it is a xy loop. Then in the last what you will see, blank space. So b r, and this is q. Okay, like this you are going to solve. Now they have told take one example. Okay, 0 0 1 1. Okay, for this we have to track, it seems, track and write. How to write, I'll show you 2 steps, remaining you just write. Okay, so obviously this is the symbol we write, okay, in order to track. So obviously first I'll be in Q naught state, okay, and I want to read all this. Whatever I want to read, I'll write it here, and blank space, you know, it is always here. So first time when I'm tracking this, okay, you should always draw it 0 0 1 1, and last we will have blank space, right? So first time when I'm reading this 0, I will make it as x, right? So I'll make this 0 as x, and from Q naught I'm moving to next state, right? See, I'm making 0 as x, and afterwards I'm moving towards Q1 state. So Q1, okay, and remaining whatever will be there we will write as it is 0 1 1 B. Next, now again you have to check for next letter and you have to change. Next I'll be reading this 0, right? So whatever I'll be reading, I'll write this side. Okay, that is the step. 0 I'll write this side, and Q1 I'll keep it here, 1 1B as it is. Okay, now I'm reading this 0. So obviously again 0 is here also, right? 0 0 loop. So as I read this 0, I'll be moving from Q1 to Q2 state. First you write about Q1 only. So it is something like x0, Q2, 1 1B. Similarly, take this side, read this one, everything. So answer will be something like, because you are reading x, why? Because for 0 0, we have made this as x, for 1 1 we have made y, and in the end you will be getting blank space, and finally you should be in the blank space, means it is Q4. Okay, so while writing these steps, even if you are getting wrong, make sure last state at least you will write properly and come. Okay, in order to track that, we can just write in this form also. Okay, same thing. Okay, same this thing only, it is written like this now. That is from Q, like write all the states that we have and what are the possible things, that is 0 1 x y and blank space. So from Q naught, if I go towards 0, where will I go? From Q naught, if I'm going towards 0, I will reach Q1 state. So Q1, okay, Q1 XR, because by reaching Q1 and write this combination XR, because for 0, after I read 0, I will go to the state Q1. I'm making that 0 as x and moving towards right is the meaning. So like this we have to make the changes. Okay. Similarly, there is one more question which says define Turing machine. Same, this is 7 tuples only you have to write. Okay, and design the Turing machine for L equal to 1 to the power of n, 2 to the power of n, and 3 to the power of n. So let us say that I am considering this string. Okay, so where it is 1 1 1 2 2 2 and 3 3 3, and lastly blank space. First what will happen, it will read this one. Okay, it just ignore this everything, assume that here I have written nothing. Okay, I'll do that. Okay, first what will happen, I'll read this one. Okay, this one I'm reading, I'll make it as x. So I'm reading this one, making it as x, and moving towards which side? This side. So it is right side. So right side. So as I go towards right side, I will go and find 2. Okay, so wherever I find 2, I'll make that 2 as y and move towards right side. Similarly, wherever I find 3, I'll make it as z and move towards left, because after I make see, first time only this one you will make it as x, then this as y, then this as z. Come back, again make this as x, this as y, this as z. Come back, again x, y, z. So like that we have to go. At one time you have to complete x, y, z, and then x, y, z again. So again you are going to come back with x, x, r. Now once you make one, first x, if you make as Okay, if you make 1 as x, okay, now as you go and come back, you can encounter this y also, and you can also encounter some of the ones also. So remember, in loop what we write is, while coming back, whatever we can see, that we are going to write, and we will not make any changes to that. Okay, and similarly you'll come back, then again once you are completed, you will check, right, whether everything is changed or not. So in order to check, while coming back, like you are checking now, okay, everything I have visited or not, first you will encounter x, that is written here, then you will encounter y has been written here, then you will encounter z, which has been written here. You have to put loop, because we don't know, like n can be any number of values, so put a loop for everything, and lastly you will reach to blank space, which is in the right direction. Okay, then I had told there is one question, that is note on multiple Turing machine, that we will see now. So our multiple Turing machine will look something like this. So it consists of multiple tapes, okay, and it has some finite control and finite number of tapes, okay. It has a finite control and finite number of tapes, and each tape is controlled independently with independent read and write head. So each one will have its own read and write head. You already know that Turing machine will have read and write head, right? So that finite control will treat each tape as one different Turing machine only. So as in the single tape Turing machine, this set of the tape symbol includes, here also for each tape we have end as blank space only, okay, but we have to represent it in this form now. That is, for suppose let us assume we have 3 tapes which we will be taking as A, B and C, okay. After we read, A will become X, B will become Y, and C will become Z, and direction can be left, right or stationary, okay. So this, whatever I told, I have written in the words how to write. First, state of Turing machine changes, right, from Q to P. If the state is changing, then first tape will scan P, first tape will scan X, second tape will scan Y, and third tape will scan Z. Okay, why am I telling this? You should tell like this. Okay, first tape is scanning A, second B, and third is scanning C. Now new symbols, this ABC must be replaced, right? So first tape will replace this A with X, second tape will replace this B with Y, and third tape will replace this C with Z. Now first tape head will move towards left, second will move towards right, and third will be stationary. Like that you have to explain, okay. So if you want, you can take the screenshot here. Okay, so this was the third question. Then we have demonstrate model of linear bound automata with a diagram. So in case of normal Turing machine, we had blank spaces. Here we have dollar symbol. Okay, and same, it also has finite control state, which consists of read and write head. Also it will consist of cells. Okay, the only difference between Turing machine and linear bound automata is, here the length is restricted and it cannot move towards left. In Turing machine we can move towards left. So basically linear bounded automata is the combination of Turing machine only, but the size of the input is constrained. Okay, and same, here also we define it by same 7 tuples as of Turing machine only. And here in case of linear bounded automata we have 2 tapes, and remember that this thing, okay, LBA, that is linear bounded automata, is most powerful than PDA, but it is less powerful than Turing machine. So this can give the result which is either deterministic or non-deterministic. Now I have told you 7 tuples, right? Now that 7 tuples will look something like this. It will have 2 extra states, that is Q, accept and reject. Based on the condition, this 2 will work. Okay. Okay, fine. Then there is one question that we have to design a Turing machine for set of palindromes. So you already know what is palindrome. If we read from this side and if we read from this side, both should be same. How to design that we will see now. See now they have told set of palindrome means you should design for both even and odd in one machine only. Okay. So yes, there is separate for even and odd. Okay, first let us understand how even will work. Even means we should have 2, right? I mean starting from 2, 2, 4, 6, odd is 1, 3, 5, like that. So in case of this also, see now we will make 2 directions like A and B. Okay. So A will go towards this side and B will go towards this side. Like that we have to imagine now. So here what happens is, so as it goes and reads A, it should end with A only, right? In case of palindrome. Similarly, if it is reading B, it should end with B only. Okay, that is the normal thing for palindrome. For even and odd, let's wait. First let us think of only palindrome. If it is starting with A, it should end with A only. If it is starting with B, it should end with B only. Okay, so in between we can find anything, right? It can be either A or B. It can be either A or B. Okay, and blank space you should include. That's it. Because in Turing machine we have blank space ಅಷ್ಟೇ. Now in order to satisfy the condition of even, ನೋಡಿ ಇವನಿಗೆ already ಒಂದು blank space ಇದೆ, you're going to add another blank space, so that will become even condition. And for odd you will add 2 of the blank space because already 1 ಇದೆ plus 2 ಮಾಡಿದ್ರೆ 3 ಆಗುತ್ತೆ. So 3 will satisfy odd condition. For even what we will do, we already have 1, I'm going to add another 1, so it will become 2. Okay, and lastly ಈ loop ಬಂದ್ಬಿಟ್ಟು ವಾಪಸ್ ಹೋಗುತ್ತೆ because it should keep on repeating ಅಲ್ವಾ. So ಅಷ್ಟೇ, that's it for even and odd palindrome. Both we are considering. Remember, for odd we will add extra 2, for even we will add only 1. Okay, here it is BBL, BBL, BBR and BBR. Okay, now ಇವಾಗ ಸೇಮ್ ಇದಕ್ಕೆ we are going to write the states like A, B, X, Y, B. XY ಬರಿಬೇಕು ಅಂತಿಲ್ಲ because we are not drawing it. Okay, so A, B, X, Y ಗೆ Q0 ಇಂದ ಏನಾಗುತ್ತೆ, this state if you want you can write, this is completely optional, but ಇದನ್ನ ಬರಿಬೇಕು ಆಯ್ತಾ. Like starting it will read A because in question they have given show sequence for ID ABA ABA. You have to show the sequence. And last question I have shown you, right? First what ಏನಾಗುತ್ತೆ, you will be in one state. So AB ABA first A read ಆಗುತ್ತೆ. A read ಆದ್ಮೇಲೆ it will reach to Q1 state. ಆಮೇಲೆ B read ಆಗಬೇಕು. So once you read B, it will read B and come towards this side. ಅಲ್ಲೇ A ಮತ್ತು B ಇದೆ, ಯಾಕಂದರೆ ಇಲ್ಲಿ ನೋಡಿ ಸೆಲ್ಫ್ ಲೂಪ್ ಇದೆ A ಮತ್ತು Bಗೆ. ಸೊ ಇಲ್ಲೇ ಇರುತ್ತೆ, Q1 ಅಲ್ಲೇ ಇರುತ್ತೆ. ಸೊ ದೆನ್ ಇಟ್ ವಿಲ್ ಮೂವ್ ಟುವರ್ಡ್ಸ್ ಎ ಬಿ ಎ ಬಿ ಎ ಅಲ್ಲೇ ಇದೆ ಅಲ್ವಾ. ಸೊ ಅಲ್ಲೇ ಸೆಲ್ಫ್ ಲೂಪಲ್ಲೇ ಆಗ್ತಾ ಇರುತ್ತೆ. ಸೊ Q1 ಅಲ್ಲೇ ಇರುತ್ತೆ. ಆಮೇಲೆ ವೆನ್ ಇಟ್ ಇಸ್ ಸಪೋಸ್ ಟು ರೀಡ್ ಬ್ಲ್ಯಾಂಕ್ ಸ್ಪೇಸ್, ಆವಾಗ ಇಟ್ ವಿಲ್ ಗೋ ಟು ನೆಕ್ಸ್ಟ್ ಸ್ಟೇಟ್. ನೋಡಿ Q2 ಅಲ್ಲಿ ಬ್ಲ್ಯಾಂಕ್ ಸ್ಪೇಸ್ ರೀಡ್ ಆಗಬಹುದು. Okay, so like that you have to write the instantaneous description. And ಲಾಸ್ಟಿಗೆ ಲ್ಯಾಂಗ್ವೇಜ್ ಇಂದು ಲೈಕ್ ಏನೇನು ವೇರಿಯೇಬಲ್ಸ್ ಯೂಸ್ ಮಾಡಿದ್ವಿ ಅದು ಕೂಡ ಬರೀರಿ. 7 ಟಪಲ್ಸೇ ಇಲ್ಲಿ ಆಲ್ರೆಡಿ ಅದನ್ನು ಬರೆದಿದ್ದೀವಿ, ಅದನ್ನು ಮತ್ತೆ ಬರ್ದಿಲ್ಲ. ಟ್ರಾನ್ಸಿಷನ್, ದಿಸ್ ಇಸ್ ಓನ್ಲಿ ಟ್ರಾನ್ಸಿಷನ್, ರೈಟ್? ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಶೋ ದಿಸ್ ಇಸ್ ಓನ್ಲಿ ಟ್ರಾನ್ಸಿಷನ್, ಮತ್ತೆ ಬರೀಬೇಕು ಅಂತ ಇಲ್ಲ. ಬಟ್ ಈ ಟೇಬಲ್ ಹಾಕಿದ್ರೆ ಇಟ್ ಇಸ್ ಕ್ಲಿಯರ್ ರಾದರ್ ದೆನ್ ರೈಟಿಂಗ್ ಇಟ್. ಓಕೆ, ಟೇಬಲ್ ವಿಲ್ ಗಿವ್ ಯು ಮೋರ್ ಕ್ಲಿಯರ್. ಲೈಕ್ ಹೌ ಐ ಆಮ್ ಟೆಲಿಂಗ್ ಇಸ್ Q0 to A. So Q0 from A is going towards Q1. So Q1 is written here, and this B matte R you write it as it is. Similarly Q0 on B, Q0 on B, it is going towards Q4. So write this Q4 as it is. Illi last 2 letters inide that will come as it is. For every thing it is same. Okay, Then they have asked to write a note on deterministic, non-deterministic Turing machine. So as the name itself says, it is a theoretical model of computation that extends the concept of normal deterministic Turing machine only. But the only thing that gets changed is, this is the theory. You can pause the video and read. Okay, fine. The only difference here is, see, we have Q accept and Q reject, right? Just like how we had in linear bounded automata, same thing. Okay, so you have to write the full form, that this everything. So Q accept and Q reject state. Remember, if accept state starts from QYD, Q1 QY, Q1 Y1 D1, Q2 Y2 D2, in that case we will reach up to K, right? So we'll go on reading. That K must be finite and D indicates the direction. Okay, and you have to write the key features of non-determinism. Okay, first feature is only non-determinism. That is, at any step, the Turing machine, not the Turing machine, the machine can choose among several possible transitions. Whichever is possible for it, according to correct sequence, it will be solved. Okay, and this can be often visualized as a tree of computations. Like sequence of transition can be represented in a tree. Then we have something called as, we had Q accept and Q reject, right? Same you have to explain. So acceptance condition, so if an input symbol is accepted if at least one computation branch lead to accept state. So if all branches lead to reject state, then the entire string is rejected. Then we have parallelism, is nothing but this non-deterministic Turing machine can explore all computational branches simultaneously. Meaning of parallelism is working simultaneously. So for that we can write this thing, L of m when n equal to L of m d. If mn is a non-deterministic Turing machine, then there is a deterministic Turing machine which becomes equal to this. Okay, I'll just show it again. Same thing. Okay, just write the full form. For one more thing, for transition it is Q into this thing, where this Q indicates 2 to the power of Q into F. This toe is nothing but left into right. This is not there, this is cancelled. Okay, then we have right, like in one question paper it was asked, what is Turing machine? Explain the applications of Turing machines. So if we have, see, Turing machine has both theoretical and practical applications. When it comes to theoretical, it helps in language recognition. It recognizes recursively enumerable language. Then it helps in functional computation, like if you want to calculate the or keep in track with number of letters and all. Then modeling algorithms, it can be used. And complexity theory, you already know what is complexity, like the code is getting compiled in this many number of seconds, that line you have to write. Okay, then universal computation, that is, universally we can accept the Turing machine as a standard method in order to maintain the equity, like everyone should get one standard answer. So that is why universal computation. It can also be used in AI, robotics, programming languages, cryptography, and security and verification. Cryptography is nothing but if I want to send something high, this can be this thing, what is that, it can be secured or it can be changed from this language to any other language, just like a code word. So if I want to change this high, I can change to something like KM, something like that. Okay, it will get changed based on the cipher techniques. That is only cryptography. Then same question they have asked one more, L equal to A to the power of n and B to the power of n. I think this I have explained. Same thing. Okay, here they have taken zero to the power of n and 1 to the power of n. Illa same, 0 badlige A power n matte P power n kotru same barutte. You know this already, right? This is n. Okay. Then they have asked one thing, explain the programming techniques in Turing machine. So before I explain the programming techniques, you should know that multiple track Turing machine is different, multiple tape Turing machine is different. Okay, in case of multiple track, you should write track 1, track 2, track 3, and we will have a control unit, and one tape head is there. Among all, only one tape head will be there to read. There, in case of tape, for each tape we had one head, but here it is only one tape head. And if there is K symbols, then we will have K tracks. Okay, and in case of Turing machine defined, we had only single case and single tape. In multiple, we will obviously have multiple tape. And in multiple track Turing machine, a single tape is assumed to be divided into several tracks. Okay, and the tape alphabet is required to consist of K tuples. Whatever alphabets we have, right? So that is considered as K tuples. Then for that K tuples, if we want to keep track, we will have K tracks. So the only difference between the standard Turing machine and multiple track Turing machine is the set of tapes. So in case of standard Turing machine tape symbols, there are actually this we have to write TOC, and in case of multiple track Turing machine, it is TOC to the power of K. K is nothing but this track. That is the only difference that we have. Now, in order to keep the track, the techniques is, the first technique is called subroutine. So subroutine is nothing but just like we know, right? In subroutines, okay, in case of computer languages, if we ask something to do, if we assign some task to the computer that is repeatedly asked, okay, recursive function, you know, right? It will be calling the same function again and again. For that, we can use the method of subrouting. So we can implement one Turing machine and we can call that Turing machine only again and again. So that is only subroutine facility, same as recursive function. And remember, this subroutine will have initial and return state, because it has to keep on returning again and again. Clear, right? Yeah. So along with this subroutine, we also have this thing, okay, that is stationary head. Stationary head is, the head will become constant and it keeps on repeating. Okay. And also we can have storage in the state. So each state can fix the storage. That is the third technique. Okay, if you remember 3, it is enough, I think. Okay, coming back. Here there is one question where they have asked, design a Turing machine to accept strings formed on 0, 1 star and ending with 0, 0. See, in order to draw Turing machine, first I will show how DFA will look like. Same thing I will convert to this thing, Turing machine. That is easy for you. Okay, so ending with 0, 0 means in this end I should have 3 zeros. Okay, zeros can repeat because at the end I should have 3 zeros. Ashte. In the starting it can be 1 or it can have zeros, right? So instead of putting comma 0, I'll write it here as 0. So any number of time it reads 0, we already have a loop of 0, so it will get repeated. So see now, as I'm reading, I need to get 3 zeros, okay? 3. So first time I will read 1 0, okay, and I'll move from Q1 state to Q2. Now I want to read another 0, but if instead of reading this 0, if 1 is coming, what I should do? I should send this back to 1, back, okay, where I have to send, wherever 1 is getting accepted. Here 1 is getting accepted, right? So I'll send it back and this will send it back to here. So in between these zeros, wherever we get 1, we have to send it back. Okay. Now for the same thing, I will draw Turing machine now. So it should accept 0, it should not change to anything because they did not ask us to change. So I'll accept 0. I will not change anything. I'll keep it as 0 only. I'll move towards right. Same thing. I'll accept 0, keep it as 0 only, move towards right. So like this I will do 3 times because in the question they have told continuous 3 zeros. So I'll read continuous 3 zeros, and in between that zeros, if I'm getting 1, I should send it back, right? So that sending back is been denoted like this. Okay, sending back and coming to moving towards right only, because see now I'm reading this 0, I have read. I want to read next 0, but if 1 is coming, I will send it back, but I will move forward only, right? Going on checking with other letters. So that is why you have to represent it like this. Okay, then you may ask why there is a loop for zeros and ones. See, zeros and ones can come again and again. Even though it comes, I am sending it back. Okay, so that is why I have written 1 here. Now same thing, you are going to write it in the table form for the transition, and they have asked you to trace this. Okay, 1 0 1 0 0. First one, if 1 comes, what will happen? It will stay in Q1 state only. Then if I want to read 0, it will go to Q2 state. Then there is 1. Again I'll come back, read 1, I'll go. So lastly, if you read last 0, you should be in Q4 state. So last you should get this answer once you trace this. Okay. Same thing I've written. Where is that? Yeah, same thing, but last state you should get as Q4. Try tracing it. Obviously you'll get last Q4 only because that is the final state. Okay, yeah. Then palindrome we have solved. Now let us learn what is this recursively enumerable. So recursively enumerable acceptance means, so let us say that our Turing machine accepts all the languages, even those that are recursively enumerable. So recursive means repeating the same set of rules for any number of times. That is the meaning of recursive. Enumerable means refers to some list of elements. Okay, and this list of elements can be any list, and like computational functions and all. What are these computational functions? Those are the mathematical functions like operators, okay, such as plus, minus, division, and this is what power. Okay, so anything can happen but not multiplication. Please note this in recursively enumerable acceptance. This is the condition. Okay, and multiple tape Turing machine I have told. See, multiple tape Turing machine is different. Multiple Turing machine is different. In case of multi-tape, we will have multiple tapes. In case of multiple Turing machine, it is k number of tapes. Okay, and they have asked undecidability problem. Undecidability problem means if it is not possible for me to solve any question without like having the algorithm, having the everything I have, but still I can't solve it, that is only undecidable problem. So it can either lead to correct yes or no. I cannot decide it. It's not it may have answer, it may not have answer. That is secondary, but I can't decide only, even though I have a time, even though I have an algorithm. That kind of problem is called undecidability problem. Okay, so in order to reduce this, okay, first of all, this problem will lead to halting problem. So in order to reduce this halting problem, halt is nothing but stop. We can't decide, we will pause there only. That is only halting problem. So we can have the concept of reducibility, that is P1 less than or equal to P2. Now this is a technique where we use a solution for problem P2 to solve P1. That means now I am solving question P1 and I can't just decide. Now this is what now? Undecidable problem, and I'm like it leads to what? Halting problem. So in order to solve this, I will create another problem. From that solution, I'll come and approach this now. Are getting me, right? Yeah. Suppose if you have any internal marks issues with the teacher, you'll go to HOD. You'll ask him, talk to him, and he may talk to the teacher. Something like that. Okay. So this is the condition. Okay, so if P1 is reducible to P2, I'm just reducing the problem, just like how we had divide and conquer. Same, I'm going to reduce it, and P2 will become decidable. Similarly, then P will also become decidable, P1. Just you are going to divide P1 into P2. If P2 is decidable, then obviously P1 must be decidable, right? Same thing. Then we have halting problem in Turing machine. Halting is nothing but you will just be stuck. You will not be able to move. It is just like getting exited from there, something like that. So we have two cases. So for certain input of string, okay, if there is a string and there is some input with some configuration machine, okay, let us say we have in Turing machine only we have different kind of things. So let us assume this is our string and we have one Turing machine and we are going to make it accept. So machine will halt, okay. It can be anything, it can be undecidable condition and all. So machine will halt after some finite amount of time in first case, and the second case is the machine with certain input string, even though it knows the string and even though it knows the configuration, it will never halt. That is the two condition. It can either halt or it can never halt. Okay, now the halting problem states that if there are any machine with input, let us say that input string consists of what? Basically the data that can be determined. So either it will never halt or it will halt. You have to put in a question mark. You have to just justify that the answer is no. That means halting problem is always unsolvable. You can recognize the ways to solve, but it is unsolvable, because we cannot guess whether it will halt there only or it will never halt. That's the problem. Then we have something called as PCP problem, which is very easy. PCP stands for post correspondence problem, which will be asked for 5 marks. Okay, so they'll just give in the question explain PCP problem. Remember that PCP is undecidable, but we can recognize, okay, it can be solved, but we cannot decide. Okay, something like that. Now let me consider that I have 4 dominoes box. Okay, so this is my first, second, third and fourth box. Now in order to solve this, there is one condition. Okay, see now, the numerator and denominator should be same. Okay, like that we have to go on arranging. Fine. Now here in which dominoes the A and B is same, that is numerator and denominator. Here the numerator and denominator is same, right? So I will take this A and A. Okay, now I got this B. Okay, because this same thing I have written here, numerator and denominator is same, B I have written. Now for this B, in the numerator place it is empty. So if here I have B, here also I should be getting B. So from where I can take? Here in this first dominoes I have B in the numerator. So I will write that as it is. Clear? Fine. Now you see, we have CA here. Do I have CA in other thing in the numerator? Yes, I have CA. So I will take this here now. Now, okay, now what happens is you have taken CA and here it is A. AA is matching, but this C is not matching here. Always compare denominator with numerator. Okay, so AA is matching, but here I don't have anything to match. So I should take something next, that is A only. So A, what is left now? AB is left. So I'll take that AB and A. Then what happens is, see now, here I have AB. Is there anything that can match my numerator with AB? Yeah, I have this AB. So AB will be written, and CC. C is nothing but this C. Same thing you have to write. Like that you have to match and write. Okay, same thing I have written. In what order I have matched, right? First I have taken AB. AB is matched. Then C is matched. Then the AA will be matched. Similarly, if they are, the question can be given in this also, this form also. Question will not be given. You have to take the example and write. So either it can happen in alphabets or it can happen in zeros and ones. Now, same thing. Okay, we will say that we have considered 3 things. Okay, this is first, this is second, and this is third one. So here what will happen now is, in case of 1, Okay, now same thing. I'll write this. This is numerator, this is denominator. Numerator, denominator, numerator, denominator, and numerator and denominator. Now you see, okay, 1 and 1, it is same. Okay. And here also you can see 1 0 1 0 is same. So compared to first one, which is the like in the second dominoes, I can see 2 characters are same. So that will be my first preference. So I will write this 1 0 as it is and 1 0 as it is. From where I have picked from dominoes 2 and 3. Okay, so 1 0 and 1 0 I will write as it is. Now you see there are 3 ones here, but I don't have anything. That means I can add this ones. I will check in other. Yeah, once I check a denominator of other 2 dominoes, here I am finding extra ones. So these 3 ones and this 3 ones can be combined. So in the next stage what I will do, I'll bring 3 ones. Okay. Wait, I'll just rewrite and show for you. So in the first step what I'm going to do, I'm going to check the numerator and denominator. Here, yes, it is same. Only 1 is same. But here 2 is same. It will be better for me to take this, right? So I'll take this now, 1 0. And denominator is also same, 1 0. Now, after reading this 1 0, I have these 3 ones, right? These 3 ones. Now I will check, are there anywhere 3 ones again that I can add in the denominator? Yes, in dominus 1 I have these 3 ones, right? So I'll just bring that 3 ones here. Next what happens is this 1 1, okay, this 1 0 is left out now, and this 1 is left out. So this 1 and 1 is matching, so 1 1 I will add. Then this 0 and 0 will be matching, so 0 and 0 I will add. So that this is how the PCB concept works. Here I am officially ending all the 5 modules. For all the 5 modules I have completely covered model question paper 1, 2 and December paper, June July paper and June July makeup paper. Module 4 and 5 is easy, and module 4 and 5 consists of very repetitive questions. There is a rumor that in module 4 GNF is not there, but you should study because in the syllabus they have given starting first concept of module 4 is normal forms. Normal forms means only this thing, CNF and GNF both are included in the syllabus, so kindly don't skip it. Okay, December paper earlier, I don't know why they have given this thing, what is that, grace marks, but don't expect in yours because you already know how the previous 2 subjects were. So kindly study well. If possible, I'll try uploading one more video which consists of all this thing, theories separately and numericals separately. Let's see how it goes, and definitely you can expect more videos on TOC. Kindly get subscribed if not, and also do share this video with your friends. That will help me a lot to reach out the students, and do hit a like if you have followed all 5 modules. Also let me know if you have gone through all the 5 modules, because I want to check whether all 5 modules are being checked by you or not. And I'm also thinking to do TOC rapid revision. In that rapid revision from module 1 to 5, I'll be covering each concept one important question. So that will be helping you a lot. So if I get at least 50 comments for this video asking for revision, I'll definitely go ahead and do the revision video. So 50 comments I'm expecting, because I have put lot of efforts. At least if 50 people found it helpful, I'll be so happy, right? And also I'm expecting at least 100 likes for this video, because see, if you like, the algorithm of YouTube is, if you like, it will reach to someone else. And obviously I've told the monetization for these videos are not on, because it's not meant for this purpose. Okay.